Hi kids, I hope everybody is fine. Now in this video, we'll solve numericals from chapter Sound from class 10. This is from Concise Physics, exercise 7. So let's get started. The first sum. Let us see what they have told. The wavelength of a wave produced on the surface of the water is 20 centimeter. If the wave velocity is 24 meter per second, calculate the number of waves produced in 1 second and the time in which one wave is produced. First of all, write the data which they have provided us. Wavelength they have given as 20 centimeter and wave velocity denoted by V they have given as 24 meter per second. What they have asked? The number of waves produced in 1 second. First thing, number of waves produced per second. Per second. Very easy. Now, just remember the definition of frequency. So this is nothing. Number of waves produced per second is nothing but frequency. Remember? And we have a relationship between wavelength, wave velocity and frequency. That is V equals to F lambda, which means F equals to V by lambda. Yes or no? So your frequency is what? V by lambda. Now V is what? 24. Lambda is 20 centimeters. So 20 by 100 meter. So this is 20 by 100. 1 time, 5 times. So that's 120 waves will be produced per second. Done or not? I'll just write like this. Yeah, 120 waves per second. Now the second part they've asked, the time in which one wave is produced. Just remember the definition of time period. That is the time required to produce one wave. So time period is 1 by F. That's 1 by 120 second. You can change it to decimal also. Okay. Yeah, they have given the answer in decimal. 8.3 into 10 to the power minus 3. If you solve this, you will get the same thing. Done. Now let us do number 2. Now look at number 2. Calculate the minimum distance in air required between the source of sound and the obstacle to hear an echo. Take speed of sound in air as 350 meter per second. So the speed of sound in air they have given as 350 meter per second. Suppose this is your source. Okay. This is the obstacle. Then what should be the minimum distance to hear an echo? So we know one thing, that the minimum time after which the reflected sound should reach the source after the original sound is heard is 0.1 second. We know this fact. So we have minimum time required. We have velocity. Now we know distance. Suppose the distance is d. Then from here to here is d. From here to here is d. So twice of distance is velocity into time. Yes or no? Which means distance is velocity into time by 2. Where d is the distance between the source and the obstacle. Just simplify it. Put the value 350 multiplied by 0.1 by 2. This point goes away. 10 comes down. 0, 0. This is 17.5 meter. Which means the minimum distance required to hear an echo is 17.5 meter. Remember this. Time should be 0.1 second. Then only you should hear the reflected sound after you hear the original sound. Done? Sure. Let us look at number 3 now. Now look at number 3. What should be the minimum distance between the source and reflector? Reflector, minimum distance they are asking. Okay. In water, so that the echo is heard distinctly, the speed of sound in water is 1400 meter per second. Now, just like the previous sum, the time required will be 0.1 second. Isn't it? So, what is 2d? Because the sound waves travels from here to here d distance and then again comes back d distance. So it's 2d. So total distance is velocity into time. So d is velocity into time by 2. So D is what? 1400 by 2, 700 into 0.1, 70 meter. So the distance should be at least 70 meter to hear an echo distinctly. Done? Sure. Now let us look at number 4. We'll do it over here only. There is enough space. Number 4. What they're saying? Sure. A man standing 25 meters away from the wall produces a sound and receives the reflected sound. Calculate the time after which he receives the reflected sound. If the speed of sound in air is 350 meters per second, will the man be able to hear a distinct echo? Explain your answer. Look away, what is given to us? A man standing 25 meters away from the wall. So this is your man, this is the wall, and the distance is how much? 25 meters. This is your wall. Okay. Calculate the time in which he can hear an echo, reflected sound rather. The velocity is given as 350 meters per second. Now look carefully. We know 2D equals to V into T. So 2D equals to V into T, which means T is 2D by V. Again 2D because D and D. Okay. It goes and comes back. So twice into 25. V is what? 350. Am I clear? Yeah. So this is 50, but this is 1 by 7 second. Am I clear or not? So T is what? 1 by 7, which means 1 divided by 7, 0. So this is, just solve it. This is 4s are 28, 2, 7, 2s are. So 0.14. Okay. I'll take one more place, So 6, 0, so 7, 8s are 56. So this is 0.143 second. Isn't it? After which he will hear the reflected sound. Simple by formula. 2D equals to V into T. Now what they've asked. Will the man be able to hear distinct echo? Definitely yes. Why? Because the time taken is more than 0.1 second. Because the minimum requirement of the time to hear the reflected sound after which the original sound is heard is 0.1 second. You hear the original sound 0.1 second and the reflected sound, if it takes at least 0.1 second to come back, then only you can hear an echo. So yes, in this case. Now let us look at number 5. Now look at number 5. A radar sends a signal to an aeroplane at a distance 300 km away with a speed of 3 multiplied by 10 to the power 8 meter per second. After how much time is the signal received back after reflecting from the aeroplane? Now what? We know radar is a detecting system which uses radio waves to determine the distance, angle, velocity of various objects, maybe an aeroplane or a guided missile. Okay, suppose your aeroplane was over here. Okay, your aeroplane is over here. Now, what they have told? A radar sends a signal to an aeroplane at a distance of 300 km away. So this distance is 300 km from the radar. And the speed, radio waves, is 3 multiplied by 10 to the power 8 meter per second. The radar sends a signal. Yeah. After how much time is the signal received back? So they're asking time. Again, we know 2D equals to V into T. D is over here 300 kilometers. So 2 into 300 kilometers, we change it to meters. So we'll multiply by 1000. Yes or no? Velocity is 3 multiplied by 10 to the power 8 multiplied by time. Okay. The waves goes and then again comes back. The signal. So this is how much? 2 into 300 into 10, 100,000 by 3 into 10 to the power 8. That is your time. Now look carefully. This is 2 5 zeros. Send 10 to the power 8. 5 goes away. So 10 to the power 3 will be left. 3 cancels out. So 2 by 1000, which is 2 into 10 to the power minus 3 second. This much time it will take. Isn't it? Yeah. 2 into 10 to the power minus 3 second. After how much time is the signal received? After this much time. Okay. This was number 5. Chalo. We'll do number 6. Over here only we'll do number 6. A man standing 48 meters away from a wall fires a gun. Calculate the time after which an echo is heard. The speed of the sound in air is 320 meters per second. Very easy. See what is given to us. Speed is given to us 320 meters per second. The distance is given to us 48 meters. They've asked for the time. Again, 2D equals to V multiplied by T. Isn't it? So 2D by V equals to T. Just substitute the value. 2 multiplied by D is how much? 48. 320. Yes or no? So 2 one time. 2 160. 16 one time. 16 10 times. And 16 3 times. So that's 0.3 second. Isn't it? Very easy. Simple. Just use the formula. Yeah, 0.30 second. Same thing, you know. So it's 0.30 second. Chalo. Now we'll do the next one. Number 7. Number 7. A ship on the surface of water sends a signal and receives it back from a submarine inside water after 4 seconds. So the time taken to receive the signal is 4 seconds. Calculate the distance of the submarine from the ship. The speed of sound in water is 1450 meter per second. Very easy. A ship, suppose this was your ship. Okay. And there was a submarine. So the signal goes and comes back. Suppose the distance is D. Then again, 2D equals to V multiplied by T, which means D equals to V multiplied by T by 2. Very simple. So D is what? This is your submarine. Doesn't look like, but still assume it. So D is what? 1450 multiplied by 4 by 2. That's how much? 2900 meters. That's 2.9 kilometers. That is 2.9 kilometers. Done. Very easy. It was the same formula we are using, you know. Time and velocity was given to us. Look at number 8. This looks interesting. A pendulum has a frequency of 5 vibration per second. Frequency of 5 vibration in 1 second. They've given this. An observer starts the pendulum and fires a gun simultaneously. He hears echo from the cliff after 8 vibration. Hears echo after 8 vibration. Remember. Okay. If the velocity of sound is 340 meter per second, find the distance between the cliff and the observer. Now look over here. Time to hear the sound will be equal to time in which 8 vibrations takes place, isn't it? Because the pendulum completes 8 vibrations and then you hear the sound. So how much time is taken to complete 8 vibration? See, 5 vibration in 1 second. So 8 vibration, I can write directly 1 by 5 multiplied by 8 seconds, and this is your time. This much time it takes to hear an echo in this case. Now we know 2D equals to V multiplied by T. So D will be what? V is how much? 340. T is what? 8 by 5 by 2. This 2 comes down to 1 time to 4 times. 5 1 time. 5 68 times. So D is what? 8 4s are 32. 24 27. This is 272 meter. That should be the distance, isn't it? Yeah, that's the answer. 272 meter. Chalo. Now look at number 9. A person standing between the two vertical cliffs produces a sound. Two successive echoes are heard at 4 second and 6 second. Calculate the distance between the cliffs. Speed of sound in air is 320 meter per second. Which means this was a cliff, first cliff. The person is standing over here, suppose. And this is the second cliff. Okay. He hears two echoes. This is the nearer one. So he hears the echo after 4 seconds. This is at a little distance more than this. So he hears an echo after 6 seconds. They need the distance between these two cliffs. And speed of sound is given as 320 meter per second. This is your first cliff and this is your second cliff. Now, for the first cliff, suppose this is D1, this is D2. Twice D1 equals to V multiplied by T. Yes or no? D1 and then again D1. Twice D1. So D1 is V into T, that is 4 by 2. So that when we solve, we get 640 meter. Now for the second cliff, if you look carefully, again 2 D2 equals to V into T. T2, यहाँ पे T1. So D2 equals to V 340 multiplied by T2, which is 6 by 2 to 1 time to 3 times, that is 0, 3 4 is 12, 1020 meter. So the total distance between the two cliff will be D1 plus D2, which is 1020 plus 640, that is 1660 meter. So that's the distance between the two cliffs. Yeah, just take out the distance, D1 and D2 and then add it. Simple. Now let us look at number 10. Now look at number 10. A person standing at the distance x in front of a cliff. So a person standing at a distance x. This distance is x in front of a cliff. Fires a gun. Another person B, this is A, okay, person A. Another person B standing behind the person A at distance y from the cliff. So this is y from the cliff, okay, from the cliff. Here's two sound. This person, when he fires a gun, when A fires a gun, B hears two sound, okay. Two sounds of the fired shot. After 2 seconds, he hears a sound, and then again after 3 seconds he hears a sound. Calculate x and y. Take speed of sound, V of sound, as 320 meter per second. Now try to understand. This person fires a gun. So this person, so the sound travels like this once. So he hears the first sound after t1 second. Then what happens? The sound from A travels to the cliff and then it travels to B, isn't it? In this case, he hears another sound after 3 seconds. So the first sound which he is hearing is not due to echo. Simple case. Sound from here travels till here. Suppose this distance A to B, I'll take it as Z. Then distance equals to speed into time. Yes or no? Simple. There's no echo. For the first sound, there's no echo. So distance, Z. You could have taken D also. Doesn't matter. Z equals to S, 320 into T, that is 2. So Z is 640. 640 meter. Okay. What they're asking? Calculate X and Y. Now, look over here. For the second sound, this was for the first sound. For first sound, when the time was 2 seconds. For second sound, just be careful. Your time is 3 seconds. Yes or no? Now in this case we have echo. But the distance over here is x plus y. X plus y starts from here, goes to the cliff, and then again return back, reflected back. So the distance, total distance, which we were using in the earlier formula 2D, over here we'll write x plus y, and that is equal to distance. Total distance is velocity into time. Total distance is velocity into time, speed into time. So 320 into time is 3 seconds. Yes or no? Now look carefully. X plus, instead of y, can I write x plus z? Definitely I can write that. So that's 3 to the 6, 3 to the 9. Instead of y, I've written x plus z. So just solve it. Z is, so 2x plus 640 equals to 960. So 2x equals to 960 minus 640. That is how much? 320. So x is 160. Done. X is 160. Yes or no? Now look at this. X is 160. We got. And z is how much? 640. So y will be what? Look at the diagram. X plus z. This is 640 plus 160. 800 meter. So this person from the cliff is 800 meter, and this person A is at a distance of 160 meter. Yeah, x is 160 meter and y is 800 meter. Done. Now let us look at number 11. Now look at number 11. On sending an ultrasonic wave from a ship towards the bottom of a sea, towards the bottom of the sea, the time interval between sending the wave and receiving it back is found to be the time is 1.5 seconds. They've given this. Okay, if the velocity of wave in water, velocity is 1400 meter per second, find the depth of the sea. Suppose the depth is d. So we know 2d is v into t. Remember echo. So d is v into t by 2. So d is how much? V is 1400 multiplied by 1.5 by 2. Just simplify it, isn't it? So how much is this? 700 plus 350. 1050 meter. That's the depth. Yeah, that's the depth. Simple case of echo. 2d equals to velocity into time. Done. Now let us look at number 12. Now look at 22. Figure shows the distance displacement graph of the two waves. This is your distance, okay? And this is the displacement, okay? Along y-axis in centimeters. Figure shows the distance displacement graph of two waves A and B. Compare the amplitude and the wavelength of the two waves. Now, talking about the amplitude. Okay, what is amplitude? The maximum displacement of the particle in the medium on either side of its mean position. The maximum displacement. Look at maximum displacement of A. 10 unit is given in centimeter. 10 centimeter. So amplitude of wave A will be 10 centimeter. Similarly, amplitude of this wave B, if you look carefully, it's 5 centimeter. Isn't it? The maximum displacement amplitude of B is 5 centimeter. So ratio will be 10:5. That is 2:1. That's the ratio of the amplitude. Yeah. Now what they asked? The wavelength of the two waves. You need to compare. Again. Wavelength of A. Wavelength is what? The distance traveled in one time period to form one complete wave. Look at A. It covers 8 centimeters. The distance traveled. That is 8 centimeter. And wavelength of B, if you look carefully, wavelength of B starts from here, then it goes till 16. Form one complete wave. Okay, the distance traveled in one time period, that is 16 centimeters. So the ratio will be 8:16, that is 1:2, and that's your sum. Very easy. Just see the diagram properly. Amplitude 10, 5, so 2:1. Then wavelength 8, and this is 16, so 1:2. Very simple. So this was the last sum. In this video, keep it till here. In the next video, we'll see some other chapter. Till then, take care and be safe. And if you like the video, do subscribe and share.